Okay, I am continuing to work through my final exam. We're on problem number 2. See, it says it right there. That's how you know it's problem number 2. I already did problem number 1. So in this case, I have a spacecraft as a cylinder that spins on an axis with humans on the inside. I drew the picture. Suppose you want the humans to feel an apparent weight, which is N, the normal force, right? The normal force is apparent weight. So right now, if you're sitting on your seat on Earth, like that, there's a box, that's a seat. Okay, that's a seat. Then you have the weight pulling down and the normal force pulling up, and they're equal, and you feel the weight as though you're 1g, right? But you actually don't feel gravitational forces because they pull on all parts of your body equally. You actually feel the normal force. That's your apparent weight. So we want this to be half of that on the surface of the Earth. And this has a radius of 10 meters. So how fast must it spin? So we already have a little start of a diagram right here. I'm going to draw a force diagram. It looks like this. That's it. That's the only force acting on the person is the normal force. And that's going to make the person accelerate towards the center. And so I can write, let's just call that the x direction. So F net x equals N equals MAX. But it's moving in a circle. The person's moving in a circle. So the acceleration of a person moving in a circle is going to be equal to M times omega squared R. And we want this to be equal to mg over 2. Because that would be half of the weight. So now I just need to solve for omega. That's it. So the masses cancel, which is good because that means it doesn't matter if what kind of spaceship I'm in or what kind of humans in the spaceship. They have the same apparent weight, apparent feeling. And I can just solve for omega. So omega is going to be g over 2r. Let's do that backwards. Square root. So I can put in my values. It's going to be the square root of 9.8 divided by 10 times 2. Okay, so I put 9.8, enter, 20 divided by square root, and I get 0.7 radians per second. That's it. How fast must it spin? Now, if you interpreted this, I put the omega there. You may say how fast in terms of the speed. I would count that as okay as long as you showed your work where omega equals v over r, and you could solve for v. And if you wanted to use different units, RPMs or something like that, that's cool. You don't need to do that, but that's that. Okay.